Now we are subtracting polynomial expressions. We're going to start with some fairly basic ones and get to something that's a little more difficult. In the first problem, also known as problem 8, because 8 comes first in the number sequence, right? We have x plus 3 over 4 minus 9x plus 11 over 4. For us to subtract or add fractions, what must be true about both fractions? They have to have the same denominator. Do they have the same denominator in this problem? They do. So then all I need to do is subtract the numerators. So I have x minus 9x.
Negative 8x.
That's negative 8x. I have 3 minus 11, which is?
Negative 8.
Now this is sort of an interesting point. I have negative 8x over, or minus 8 over 4.
Can be reduced.
Is there something I can factor? Is there something I can factor out of negative 8x and negative 8?
8 is 4 out of the numerator and denominator.
I could. Well, let's stick with how I phrased it. Okay. So, is there something that goes into both of these terms here and here? 4 and 8. And actually, a negative 8 goes into both of them too, right? So I'm going to factor out a negative 8. So we have negative 8 on the outside of my factored expression. And so negative 8x divided by negative 8 is?
X minus 1.
X. Negative 8 divided by negative 8 is?
1.
It's positive 1. And that is over 4. And most of you have already pointed out to me that 8 and 4 share a factor of 4. So negative 8 divided by 4 is? Negative 2. 4 divided by 4 is 1. So in the end, I just get negative 2 times x plus 1. That is the best answer. I realize that some of you are going to give me an answer of negative 2x minus 2. For today and today only, I'll say that's okay. But this is the best answer. Okay? Half credit if you get to this point. Okay. Moving on to number 16. Now in this case, we have two fractions. The polynomial is in the bottom, and we are subtracting. What must be true in order for us to subtract fractions? They must have a common denominator, don't they? And so I'm looking at this fraction. We have 3 minus 2x in one denominator. We have 2x minus 3 in the other denominator. Are they the same denominator? No. But what is the connection between those two expressions? Jesse? They are opposites. So what can I do to this? Let's just deal with this one here. What can I do to this fraction here so that I get a common denominator?
Multiply by negative 1.
I could multiply by negative 1. Sure, let's do that. The other option is you could have factored out a negative 1 in the denominator, and that would be okay too. But we know that we can multiply by negative 1 over negative 1. So let's go ahead and do that. Negative 1 times 3 is, negative 3 is? Positive 3. Negative 1 times 2x is? And so that's over 4x. And as you pointed out, that is negative. And so we're going to subtract. And I'm going to switch. I know this is not proper grammar, so perhaps I should use proper mathematical grammar. So I'm putting the positive term in front. All right, so let's go ahead and subtract. So I have 6 minus negative 4x. Subtracting negative is the same as adding. So I end up with 4x plus 6 over 3 minus 2x. Now, is there anything in this polynomial, this binomial, that I can factor out? No. So therefore, I am pretty much done. Although I do notice that I do share a factor here, right? Come on, they say. Oh, you're booing a math problem? Very, very mature of you. All right. So at this point, if you had been so inclined to factor out, if you have been so inclined to factor out a 2, that's fine, but let's just keep it here. Yay. Now there are cheers. All right. All right, for number 28, we have another fraction. And we're looking for, we're just going to subtract. So what do I have to have in order for me to be able to subtract? What must be true about the two fractions in order to subtract them, Lucy? Sorry. Common denominators. Do I have common denominators? No. All right. So the question is, what do 20 and 12 both go into? You know this, he says. Yes, Ellie? 60. They both go into 60. What will I have to multiply this fraction by to get the denominator to be 60? 3. Actually, 3 over 3, which is equal to 1. What will I have to multiply this fraction by to get it to 60? 5 over 5, which is equal to 1. All right. So 3 times 3 is 9. So we have 9 times a minus b over 60 minus, what's 5 times 5? Times a plus b over 60. Now at this point, it'd be really helpful if I multiplied out my numerators, because I have a's and I have b's, and I need to combine the similar terms, right, Hunter?
Yes, absolutely.
Okay. So my numerator, what just happened there? I don't know, it disappeared. This is what happened with the video I was making for last night. It started misbehaving and I just sort of had enough. So I'm going to shrink this a bit so that we have it, yet it's not in the way. So my first fraction, when I multiply this out, I get 9a minus 9b over 60. And I'm subtracting 25a plus 25b over 60. All right, what is 9a minus 25a? Negative 16a. Negative b squared, negative 9b minus positive 25b is? Excuse me? It's not negative 16, no.
It is,
Negative 9 minus 25 is? I'm at negative 9. I'm going. Okay, we're way slow on the uptake today. I'm not going to say that out loud. Over 60. Now, do 60 and 34 and 16 all share a factor?
yes.
Yes, they do. What factor do they all share?
2.
They all share a 2. So, what am I going to have to do to this expression? I'm going to have to simplify it further. So, what is negative 16a divided by 2? Minus 17b over 30. So are we done? Yes. Now, a better answer a better answer, I notice that both of these are negative. I don't really like that a whole lot. So I could factor out a negative 1, which would leave me with negative 8a. Hello. Plus 17b over 30. This is a better answer because it is simpler, but either way is fine. At least fine for now. All right, and finally, our last problem. We're finding the perimeter. Now, obviously, the perimeter is twice the length plus twice the width. That's the perimeter, right?
Yeah.
So, what is twice 2a? 4a. So we have 4a over 3. What is twice of 4a? In order for us to add fractions, what must be true? Common denominator. And so what do I need? So let's convert these to common denominator. Obviously, 3 and 5 both go into 15. So we have 20a over 3 plus 15. Thank you, 15. Starting to get distracted by the constant conversation. So what will I multiply the numerator and the denominator here by? 3. So I get 24a over 15. So add these together, and what do I get? 44a over 15. Now, do 15 and 44a share a common factor? No. So we're done.